Hello guys, welcome to this video. In this video, I would be showing you the results of a self-driving car trained using reinforcement learning technique maneuvering across a racetrack. Before we get started, let's briefly discuss what's reinforcement learning. Reinforcement learning is a machine learning technique in which an agent tries to solve an environment by devising a policy and taking the necessary steps and actions which will maximize its rewards and minimize the penalties in the environment. Python provides us with a simple API to test and train reinforcement learning algorithms known as GYM API. If you want to learn more about the GYM API, we can go over to their official documentation, gymlibrary.ml, and explore the API. In this video, I would be showing you the results of solving an environment known as the Box 2D environment, and particularly in it, the car racing environment. In this car racing environment, we have a high-powered race car that is moving across the tiles of a racetrack. The car can steer left or right, it can gas or accelerate, and it can brake. For every right decision that the car or the agent takes in the environment, it's rewarded. Or if it doesn't perform well, it's given a penalty and eventually the car dies out. Now going to the results of the RL algorithm, I've trained three models, one model on 1000 iterations, one model on 430,000 iterations, and one model on roughly 2 million iterations. Let's see the difference of these three models. Firstly, I'll run a model that's trained on 1000 iterations. Here we go. If you observe, the car starts to move around the racetrack. The score is increasing till 80, 90, 100 maximum, and then it goes off the track, and eventually the car dies out. Let's start again. It moves across, goes off the track, doesn't know what to do, and eventually the score will drop down and the car should die out. Starts well. So we could see that the score doesn't increase beyond 70, 80, or maximum it would go to 100 on these trained 1000 iterations. Now I would change the model to trained on 430,000 iterations, and let's see if it makes any difference. The car starts well, gets stuck somehow, and starts to move again because it's still on the track. So the score is increasing, makes a good turn, goes donuts, gets back on track. The score reaches till 270, 280, goes well, and goes off the track. It tries to get back on the track, but let's see how it goes, and it dies out. Starts well, takes a good turn, keeps well on the track, is moving pretty fast, goes off the track, and doesn't know what to do after this. It should die out. The car takes a good turn, keeps well on the track, accelerates well, makes a good turn, but eventually turns back. Here we could observe the main objective is to stay on the track because it's not a fully simulated environment. It can go behind also. Now it's off the track. The score doesn't reach beyond 250, 270 maximum on these 430,000 iterations. car doesn't know what to do and it dies out. Now let's see if more iterations make any difference. Running a model that has been tuned on 2 million iterations. The car starts well, makes a sharp turn, goes pretty fast on the track. It's going well, takes a good turn even on a sharp turn, but doesn't know what to do. Still, it hasn't died out. It's trying to get back on the track, but maybe tuning on more iterations would help it. But if we could see, the score is reaching 370, 380 maximum till now in this iteration. And it died out. Starts well, makes a good turn, keeps well on the track. The score reaches till 400, makes a good turn. 500 even crossed. So the car knows well how to keep on the track tiles, even reaches 900. And considering this environment, 900 score is considered that that environment is solved. So let's see for this iteration how this car performs. Keeps well on the track, reaches 600, 700 is a score, and eventually 920, 922. It should get back, but doesn't know. Maybe we could train on more iterations to see if it makes any other difference. But in this small video, we could see how training a model using reinforcement learning technique on multiple iterations solves the environment for us. Thank you.